dear students. I'm Aditya Gupta and a very warm welcome to this lecture on the chapter of triangles. In the last few classes, we have seen different criteria, of congruence. Then we have also seen very good questions based on those, right? Now, in this particular lecture, we'll mainly be looking at properties and inequalities related to triangles, right? So properties of a triangle and inequalities of a triangle. So let's get started. Of course, there are many properties of a triangle, like angle sum property, which we have already seen, right? Moreover, there are many kind of inequalities as well relating to the side lengths. So all of that will be taken care of in this chapter. In fact, these inequalities, they can often be helpful in real life also. How can it be? Look, if there is some place, if there is some place from where we want to go to another place, then these inequalities can actually help us determine the shortest path using those inequalities, as we'll see later. So let us start with the properties of a triangle. Sum of all the angles of a triangle is equal to 180 degree. Angle sum property, as we have already seen, as we already know. In fact, we have also proved this. Yes, how did we prove this? Using, drawing a line parallel here, then alpha, then this is alpha, so alpha, beta, beta, then this is gamma, angle on a straight line add up to 180 degree. We have proved this also using Playfair's axiom. So I'm pretty sure everyone is aware of this property already. The sum of the length of two sides of a triangle, so the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So basically, if you take any kind of a triangle, random triangle A, B, C, then A plus B would be greater than C, then B plus C would be greater than A, then C plus A would be greater than B. Okay, very basic. This is in fact known as a triangle inequality, which is very useful, no doubt, and the proof is actually very easy also. Like we can say that between these 2 points, what will be the shortest path? Obviously the straight line. So the length of this path will have to be less than any other path traversed. So clearly A plus B will be, or C will be less than A plus B, and that's what I've written here. Similarly, for all the other inequalities, it is a very obvious, property that should be kept in mind. The difference between the two sides of a triangle is less than the length of the third side. So of course, from here I can also write A greater than C minus B. So the difference is less than the third side, right? Less than. This difference is less than third side, right? So that is obviously true due to the triangle inequality itself. The side opposite to the greater angle is the longer side of the three. So basically what we want to say is, the side opposite to the greatest angle is the longest side of all the three sides of a triangle. This will prove later in Theorem 5 and Theorem 6, so don't worry. Right now, we just remember this, okay? So now, let us see. Now, as far as properties of triangle is concerned, let us focus mainly on isosceles triangle, whose property we were often using, earlier also in some questions. So first of all, what is the definition of an isosceles triangle? Triangle in which a pair of sides is equal. So pair of sides, we can also say two sides, any two sides are equal in length is called an isosceles triangle. In this given figure, triangle ABC is an isosceles with AB equal to AC, right? So this is the definition. Now we will prove the properties that if there is a triangle which is isosceles, then opposite angles will be equal. Then we will also prove another property that if opposite angles are equal, then it will be an isosceles triangle. Okay, so let us have a look at the proof. So here we have the property angles opposite to equal sides of an isosceles triangle are equal. So here we have given that AB equal to AC. We have to prove that angle ABC, basically this angle and this angle ACB, we have to prove that they're equal. So one of the ways of doing that can be to drop a perpendicular from A onto the side BC and call it AP. Okay. Now consider triangles APB and APC. APB, APC both are 90 degree by construction. So they are both right angles. Okay. Then hypotenuse of these are equal because AB equal to AC by definition of an isosceles triangle. AP equal to AP, which is a common side between both the given triangles. So we can say that by RHS congruence criterion, they are congruent. By CPCT, we conclude that these two angles will also be equal. Another way of proving the same thing can be that rather than dropping a perpendicular, we can also draw an angle bisector. Okay, we can also draw an angle bisector of angle A. So doing that, what happens is, the reason I'm telling you this second proof is that maybe some students might want to say or might want to ask that how can we be sure that this perpendicular which we'll draw will actually land between the points B and C? How can we be sure about this? Why will P not be on the extended line BC? Maybe someone wants to ask that question. So to answer that question, I'm telling you another proof that instead of dropping perpendicular, you can do one thing: just draw the angle bisector of A, then surely D will lie between B and C, because angle bisector can never go outside these points, right? Because it is the angle bisector by definition has to lie between the two arms so as to bisect it. So obviously this D will surely lie between B and C and not on the extended segments. And now also we can easily prove by side angle side angle side SS property we can apply to prove that they are actually going to be congruent. In fact, this is a much better proof using SS. So what we are saying here is that consider the triangles, okay, let me just directly write it: AB equal to AC by definition. So side, then we are talking about angle. So angle BAD equal to angle CAD by construction, because I have constructed AD to be AD is angle bisector by construction. So obviously it will divide into equal angles by construction. And second thing we can say is the side AD equal to AD common between both the triangles. So by side angle side, we can say triangle ADB will be congruent to triangle ADC, which is the correct order also of congruence, because look, AB equal to AC, which is true here. Angle BAD equal to angle CAD, yes, that is also true. AD equal to AD, so AD equal to AD, or everything is correctly maintained, so we have written correctly. So by SS we have concluded this. So by CPCT we can say angle B will be equal to angle C, hence proved. So this is the way we can easily prove that in an isosceles triangle the opposite angles will also be equal. So angle B equal to angle C we have proved. Now the second thing that we should prove here is that if there is a triangle with a pair of angles equal to each other, then prove that the sides opposite to that will be equal, thereby proving that it is an isosceles triangle. So how can we do that? The sides opposite to equal angles of a triangle are equal. We have to prove this. So how can we do this? Again, there are two methods. One of the ways can be that first we can drop a perpendicular. Okay, drop a perpendicular AP from A onto the side BC. So, okay, we have dropped the perpendicular. Now, what about these two triangles? If we consider these two triangles, we can easily observe that here we are given that angle B, angle C are equal. So, it is given to us that they are equal. And now we have to prove that AB and AC are equal. So, look, angle, side, angle, side. AAS we can apply and directly prove them to be congruent. So here, angle, first of all, we'll talk about angle. It would have been better if we would have talked about this angle first. So let us first write this angle. Angle ABP equal to angle ACP, because both of them are theta, because it is given to us that they are equal. Then angle APB equal to angle APC equal to 90 degree by construction, and of course AP equal to AB because it is a common side. By AAS congruence, we conclude that APB and APC are congruent triangles. CPCT basically gives us the final result that AB will be equal to, look, AB will be equal to AC. Okay, so I hope that this is clear to all of you. Okay, now another proof, let us have a look. Okay, another proof we'll take a look at now. Another proof can be that once again, some student might think that how can we be sure that AP will actually, that the point P will actually fall in between B and C? Maybe it will fall outside. How do we know? So for that case, for that argument, we can give another proof that okay, let us consider the triangle ABC. Okay, just a second, ABC, and let us say it is given to us this angle alpha and this angle alpha. Let us say they are given equal, because yes, of course, this is what we have to prove, that if there are equal angles, then we have to prove sides are equal. So this is given to us, so I have assumed they both are alpha. Now, or we can also call them theta, because here I have named them theta. So to avoid confusion, let us just name them theta. Okay, let me just write it properly here. Okay, now look, if this is theta, this is theta. Now what we are saying is, let us construct the angle bisector, internal angle bisector of angle A. So if this is alpha, this is also alpha, and let us now call this point as D. Now in these two triangles, angle, angle, side, angle, angle, common side. So AAS, once again we can apply, they are congruent, and as a result, the proof is complete by CPCT that AB will be equal to AC. Okay, so this is a much better proof, I would say, because it does not, it also does not depend on whether P will lie inside or outside. We are drawing the angle bisector, which for a fact we know that it will lie in between. So this is a much better proof by this construction, where we can again use AAS congruence criterion for the triangles. Triangle BAD, let's say like this, will be congruent to triangle CAD. And of course, by CPCT, AB will be equal to AC. So I hope both of these proofs are clear to everyone. Now, let us talk about some more properties here. The exterior angle of a triangle is always equal to the sum of the interior opposite angles. This is called exterior angle property. How can we prove this? Let us see. So let us say we have any triangle, first of all, ABC. Okay, what do we mean by an exterior angle? It basically means that we extend any side length, okay, any side to any side. So BC, if you want to extend, you can either extend here or here. Okay, so here or here. So you can either extend here, you can either extend here. Okay, but let us say so all these angles that are being formed, these are exterior angles. This is okay. If I extend it like this is also an exterior angle. Okay, if I extend this side here, this is exterior. If I extend this here, this is exterior. So I hope you all are getting the point how exterior angles are formed. Now, coming back to the point, let us say we have any random triangle, okay, and we create an exterior angle by extending this side. So let us say this angle we are talking about E. It is saying that this is equal to sum of the interior angles but opposite. So obviously this angle is interior angle, but it is not opposite now. It is just adjacent to this exterior angles. So what are the two opposite interior angles? These two are the ones. So sum of these two angles is equal to E. How can we prove that? Let us have a look. The way we can prove this is, let us call this angle as A, or let us call as B. Okay, let us call this angle A, let us call this angle C. Then by angle sum property, we know that ASP, what do we know? We know that A plus B plus C will be equal to 180 degree, correct? And we also know that since this is a linear pair on a straight line, C plus E will be equal to 180 degree. Yes, C plus E will also be 180 degree. From this equation, what do we conclude? That A plus B equal to 180 degree minus C. From here we conclude E is equal to 180 degree minus C. So obviously 180 degree minus C equal to this also, 180 degree minus C equal to this also. So they are also equal to each other, and hence we conclude A plus B equal to E, hence proved. This is how we have proved the exterior angle property. I hope this is clear to everyone. Two triangles are said to be similar. Okay, if their corresponding angles of both triangles are congruent and lengths of the sides are in proportion. So this is a similarity which we'll later study. Right now, you should know with just one thing, that if there are two triangles having equal angles, then they will be similar but not necessarily congruent. Okay, so the reason is triple A is not a congruence criterion, right? So for example, a 60-degree or an equilateral triangle and a bigger equilateral triangle has equal angles, right? 60, 60, 60, 60, 60, 60, but they are obviously not congruent, but they are similar. So triangles having equal corresponding angles are similar, but may not be congruent because AAA is not a congruence criterion. Of course, area of a triangle is half into base into height. How can we prove this? It's actually very easy. So let us first consider a triangle like this, and then we consider an obtuse angled triangle also in this fashion. So the way we can prove it is, okay, let me just tell you. Let me draw a better figure here. Okay, so understand this proof very carefully, because usually students are aware of the formula that half into base into height is the area, but they are not able to prove it. Like they don't know how to actually prove that area of a triangle is half into base into height. So let me tell you the proof also. Here if we have this triangle ABC, and if I drop a perpendicular at point D here, now let us do some constructions. What are those? And let us call this height h, and this, let's call this BD as x, and this entire thing as B minus x. The reason is that BC side length is base, right? So if this much is x, the remaining will be B minus x, no? Because the total length of BC is the base B. Okay, base length I am assuming to be B. Okay, so if this much I have assumed x, the remaining will be B, because B, this complete length was B. Okay, so if this much has been assumed to be x, the remaining will be B minus x only. Okay, fine. Now let us do some construction. What construction are we doing? Using Playfair's axiom, we construct a line passing through A parallel to the base BC. Okay, and then I also drop a perpendicular from here, and then I also drop a perpendicular from here. Correct? Obviously, once we do that, okay, let me just name these points F and G. We observe that since these are parallel lines, so this is 90, then this will also be 90, and this will also be 90, and then of course this will also be, so these two are parallel, right? This has been observed. So these two will also be parallel. Similarly, so this will also be 90 degree. Okay, once again, since this is 90, this will also be 90 because they are parallel. Now since both of these are 90, sum of interior angles is 180 degrees, so these two are also parallel, CG and AD. So this will also be 90 degrees. So rectangles have been formed. Correct? This is also a rectangle. Okay, look, I'll explain this properly. First, whenever we are talking about a rectangle, let us prove that a diagonal divides it into two congruent triangles. How can we do that? It's very easy actually. ABCD, if I call it ABCD, then easily we can observe that since this is a rectangle, we can say that these two side lengths will be parallel. Opposite sides are parallel, right? So if this angle is alpha, this will be alpha. This is beta, then this will be beta. So angle, common side, angle. Similarly, angle, common side, angle. Okay, so we can say that let me first write it. Triangle BAD is congruent to triangle DCB using ASA congruence criterion. How? Because look, first let us talk about an angle. So angle, let me talk about angle ADB. Angle ADB equal to ADB should be equal to CDB. So angle CDB, is it true? CDB and angle ADB. Actually, no, we have done a mistake. ADB. So we should have written CBD, right? So the order of congruence, order of points is very important. Okay. So CBD angle is actually beta, and yeah, ADB is also beta, because so reason is obvious, they are alternate interior angles. Okay, side we talk about now. What side? DB. Okay, DB equal to BD, common. Okay, common. It is very important. DB, then BD will only come. Then finally angle 2 will be what? Angle we can say ABD. Okay, ABD would be equal to, now look, ABD, then CDB. CDB. Is it true? ABD, CDB? Yes, both are alpha. So by AAS, we conclude they are congruent. So if these two triangles are congruent, their areas will also be equal, perimeter will also be equal, everything will be equal, right? So clearly here, this particular FABD is a rectangle, right? FADB is a rectangle. So if it is a rectangle, we know that these two triangles are congruent. So if this side length is h, this side length will also be h. And anyway, in a rectangle, we know that opposite sides are equal, right? Similarly, this will also be h. Now, if this area of this triangle is A1, then area of this triangle will also be A1, because I have just proved that these are congruent triangles, so they will have equal area. Similarly, this is AGCD is also a rectangle. So here, if this triangle's area is A2, its area will also be A2, correct? Now look, what is the area of this complete rectangle? The complete rectangle's area is A1 plus A1 plus A2 plus A2. But we already know that what is the area of a rectangle equal to? It is equal to, look, I am talking about this complete rectangle, FGCB, okay? Okay, FGCB, complete rectangle we are talking. So obviously its area will be A1 plus A1 plus A2 plus A2, right? And of course, its area can also be written as length into breadth. So B into H. So this becomes 2A1 plus 2A2. So twice of A1 plus A2 becomes BH. If I divide by this 2, we are getting half into base into height. So, and what is A1 plus A2? It is the area of the triangle itself, this complete triangle. So that's how we have proved that area will be half into base into height. For second case also we can prove for this triangle also. This you try as a homework, okay? And I am telling you, so basically you can try this yourself, but I am giving you a hint. For an obtuse angle triangle, how we will prove? The way we will prove it is almost the same only, just extend this side length and then drop a perpendicular. Then from this point, make a line parallel to the base and then make another perpendicular like this, then make yeah. So now what we can do is we can, yeah, I think it would be better for us if we also make a perpendicular like this. Okay, now the proof will be pretty simple, and the way you can now do it is, let's say this much is x, this much is b. Okay, now obviously two rectangles are being formed. Okay, here we can see that two rectangles are being formed, but the problem is that we might not be able to obtain half into base into height. Okay, so the best way to do it would be, let us see once again. We have extended this side length, we have dropped a perpendicular here, then we have also made a line like this, and then we are talking about another such perpendicular. Now if I am just able to find this entire rectangle's area, we'll be able to do the question, right? So now let's see how to do that. Yes, look, so the way we can do it is that we can first find that, let us say if this much area is A1, this much area is A2, then this much area will be obviously A1 plus A2, because this complete rectangle is being divided by this diagonal, right? So both the areas will be same, as we have already seen. Now another thing we should observe is that, so look, what will be, let's say this much length is b, this much length is x, this much height is h, then what will be the rectangle's area? We can say h into b plus x equal to, now what will be the complete area? A1 plus A2 plus A1 plus A2. So twice of A1 plus A2, correct? Now, how will we find the value of this x, or how will we eliminate this? Because triangle's area is just A2, correct? So now we can prove that for a right angle triangle with base and height, its area will be half into base into height, because just do this kind of a construction. These two are congruent because they are a rectangle. The rectangle's area is base into height. So triangle's area will be half into base into height for a right angle triangle. So since this is a right angle triangle, A1 will be equal to how much? It will be equal to half into x into h. So if you just put this value in here, you will get the value of A2 to be half into base into height. So that's the way you can prove it. Okay, now let us talk about this particular question. In the equilateral triangle, it has side lengths 5, 5, okay, and perpendicular drawn from the vertex to the base. Find its area and the perimeter. So this is a pretty straightforward and direct question. First, we should note that you know, how will we, if it is an equilateral triangle, perimeter will obviously be 5 plus 5 plus 5 equal to 5 into 3, which is 15 centimeter. Now, if we talk about area, how will we find that? Okay, so perimeter is very easy for us. Now, what about the area? Area will be half into base into height, as we have already seen. So half into 5 into height, where the height we don't know. But since, look, but we can easily prove that this height can be found by using Pythagoras. So let me explain what we are saying. That whenever we have an equilateral triangle, right, what happens is all of the angles are 60 degree. So when I have dropped a perpendicular here, what's happening is this is 60 degree, this is also 60 degree. So AAS, okay, AAS, so these two triangles are congruent by angle side. So we can say that since they are congruent, this length will be equal to this length. So since this complete length is 5 centimeter, it will obviously be 2.5, 2.5, and this is 5. So this is h. Now using Pythagoras theorem, because this is a right angle triangle, we can say that h square plus 2.5 square equal to 5 square. So we get that h is equal to 5 square minus 2.5 square whole under root. Okay, so that's it. Now we just put the value. So area will become 5 by 2 into, now under root, let's say I take 2.5 common. Look, what I'm doing is 2.5 square into 4 minus 1 I can write, correct? Because 5 is 2.5 into 2, right? So that's why we can write it like this. So 2.5 under root will become 2.5 only, 2.5 whole square under root will become 2.5, and inside we will get root 3. So answer becomes 12.5 root 3 by 2. Okay, that is the area, and if we want, we can further divide this to get a better answer. So yeah, this will be the answer, 10.825. So we can just plug in the values. That is all a matter of calculation. Just put in root 3 approximately 1.732, divide 12.5 by 2, and we will get the answer. So I hope this particular question is clear to everyone. Here, what once again in the solution, that equilateral triangle, all side lengths will be equal. We have drawn a perpendicular from the vertex, okay, and it divides into two equal sides, which we have proved using AAS. Okay, after that, I think it is pretty easy to observe what is happening, because we have applied Pythagoras theorem, and then half into base into height we have done. Perimeter, of course, was 15 centimeter only. Now, what about inequalities? So these are a little bit important. So let us focus what we are talking about here. If two sides of a of a triangle are unequal, then the greater side has greater angle opposite to it. So here in the given figure, let us assume that, let us assume that we have a greater angle. So which of the angles do we want to assume greater? So for instance, let us say that angle C is greater than angle B, and then we have to prove C is greater than B. So how can we do that? We will do a construction here as shown. So let me draw this triangle in this manner, okay? And here we are assuming that, let's say, angle C is greater than angle B, okay? So now what we do is that we do a construction. And what kind of a construction is that? So first of all, we are looking for an angle, okay? And now we will use theorem 6 to prove this, but for that first we need to prove theorem 6. So let us see what is theorem 6. If two angles of a triangle are unequal, then the greater angle has greater side opposite to it. Yeah, so basically first let us prove theorem 5 only, where we are saying, actually we have assumed incorrectly. We can't assume angle C greater than angle B. We have to assume that two sides are unequal. So I'm assuming that, okay, AB, let us say, is greater than AC. This I am assuming, okay? So now what we are doing is that let us consider we construct a point AD on AB such that AC equal to AD, okay? Once we have done that, these two side lengths are equal. So now join these 2 points, okay? Now if we have done that, what can we say? That ACD is a isosceles triangle. So if this angle is theta, this angle will also be theta, correct? Now obviously, since this is acting as the exterior angle, what can we say? That look, let us say this angle is alpha, this angle is beta. Obviously alpha plus beta would be equal to theta. So since theta is the sum of these two angles, we can say theta is greater than both the angles alpha and beta. So theta is greater than beta, because for example 60 plus 30 is 90. So obviously 90 is greater than both of these angles. So theta is greater than beta because it is the sum of these two angles, right? Since theta is greater than beta, and of course we can observe that angle C is greater than theta, because angle C is this complete angle, right? So this point is very important to understand, that angle C is greater than this small angle theta. So, and theta is greater than beta, so we can say, and what is beta actually? Angle B itself. So from here we can say angle C is greater than angle B, hence proved. So look, what was the angle opposite to side AB? It was angle C, right? And what was the angle opposite to AC? It was angle B. So that's what we have proved, that the greater side has greater angle opposite to it. So since this was assumed to be greater, look, we have actually found that angle C also will be greater, which is the angle opposite to it in comparison to angle B. So we have proved that this implies angle C greater than angle B, okay? Now let us see this theorem, theorem 6. If two angles of a triangle are unequal, the greater angle has greater side opposite to it. The proof is pretty easy. So let us assume here this kind of a triangle ABC, and let us assume that angle B is greater than angle C. If I have assumed that, we want to prove that the greater angle has greater side opposite to it. So AB is greater or AC is greater, that we want to find out. So the way we can do it is that we can consider here something like this. Look, since B is greater than C, we can construct angle C like this, because B is, look, if we have 60 greater than 45, so obviously from a 60-degree angle I can construct a 45-degree angle and something will remain also. So since here we have basically angle B is greater than angle C, what we can do is that we can either use theorem 5 or we can use theorem 6 to prove it. So first I'll tell you or we can, not theorem 6, sorry, or we can use basically some logic to prove it, but I think it will be much easier using theorem 5. So the way we can do it is by contradiction. So assume to the contrary, that that AC is not greater than AB. Okay, that would imply either AC equal to AB or AC is less than AB. If this is the case, then since AB and AC are equal, then these two angles must be equal. But we have already assumed that angle B is greater than C. So this can't be the case. This is rejected. This is a contradiction, right? Similarly, if this is the case, that if AC is greater than, if AC is less than AB, so using theorem 5, we can say that since AB is assumed to be greater here, angle opposite to AB will be greater than angle opposite to this side, which is angle B. But this is obviously a contradiction and not true, because angle B is greater than angle C, not angle C is greater than angle B, right? So both of these are rejected. So our initial assumption must have been wrong, because we have shown a contradiction, and hence the only possibility is that AC must be greater than AB, hence proved. So we have proved both these theorems. Now let us solve this question. Show that AB is greater than AC. So obviously this angle will be 80 degree, because they 100 degree plus what angle will give us 180 degree, because these are lying on a straight line, 80 degree only. So since 80 is greater than 40, AB will be greater than AC. Okay, using theorem 6. Theorem 6 we can use, which we have just studied. The greater angle has greater side opposite to it. So this is greater angle, so side opposite to it will be greater, right? Now, how will we prove AB greater than BC? So AB, BC we are talking about. So how much will be this angle? Using angle sum property or exterior angle property, 40 plus how much will give us 100? 60 degree, right? So that's how we can find this angle. Now, let us talk about BA. This is basically BA and BC we want to compare. So since 80 degree is more than 60 degree, BA will be greater than BC, BA greater than BC, hence proved. Similarly, BC, we can also write CB greater than CA. So C is the common vertex here, right? So obviously 60 degree is more than 40 degree. So side opposite to 60 degree will be greater than side opposite to 40 degrees. So CB greater than CA. So easily we have proved these concepts using theorem 6. These questions using theorem 6. Here is the solution also. Okay. First we have found basically the angle, using exterior angle property, angle A, we have found 60 degrees. Similarly, C also we have found. And then we have used the theorems to solve the question. So I hope that this is clear to everyone. This is the most complete way of writing the solution. Okay, step by step, proper approach. Okay, so you all can just copy it down, so that in exam you can write, in board exams you can write in this manner. Okay, now here we have some questions. If the sides, okay, first let us talk about this second question. This is easier. Name the smallest angle in this triangle. So let us say this is angle A, this is angle B, this is angle C, of course. Now look, 6 is greater than 5. Okay, so we can say BC is greater than AC, correct? So the angle opposite to BC will also be greater than angle opposite to AC. Yes, using theorem 5, this we have written. Similarly, we can say that, what can we say? We can say that BC is less than, which two sides? Yeah, BC is less than AB, because 6 is less than 7. Then what is the angle opposite to BC side? Angle A will also be less than the angle opposite to AB, which is angle C. So what we are seeing is that angle C is greater than angle A, and angle A is greater than angle B. Okay, so obviously the smallest angle here is angle B only. correct? So the smallest angle would be angle B. Okay, I hope this thing is clear to everyone. If the sides of a triangle are given by 3, 4, 5, base is 4 centimeter, altitude is this much, find the area and perimeter. So of course, it is very easy to see that perimeter would be 3 plus 4 plus 5. 7 plus 5, 12. Okay, 12 centimeter. Now, altitude is given to us. Let us see. Just a second. Let me draw a better diagram. Four is the base, 3 is here, and 5 is here. Okay, now 3.2 is the altitude of the triangle. Okay, so area we have to find, perimeter we have to find. So this question is easy only. We should note that this is a right angle triangle, because 3 square plus 4 square will be equal to 5 square. Okay, so this is 90 degrees, so its area will be half into 4 into 3, which is 6 only. Yes, so this is okay, but area it is given here 6.4. So clearly this question is incorrect, because area will come out to be 3 4 are 12 by 2, 6. Now what should be the correct question then? What should be the altitude from all the different vertices? So look, from, let us name this triangle ABC. So from A, obviously the perpendicular length onto the base is 3. From C, obviously it will be 4. Now what about this? How much will be this altitude? So look, area can be written as half into 5 into height, but we already know area came out to be 6. So height will come out to be 12 by 5, which comes out to be 2.4. So here it should have been 2.4 centimeter. Okay. So sometimes even if the question is wrong, by applying our own brain, we can correct it. So I hope this is also clear to everyone. So I hope you all enjoyed watching the lecture and learned something new. And basically this concludes the chapter of congruence of triangles, their properties, and I hope you were able to understand all the concepts. Once again, thanks a lot for watching. Stay safe and enjoy, and bye-bye.